In this video, we want to solve for the intersection between two lines in the general form, but we're going to develop a new technique called elimination. So we're going to work with two familiar equations that we had used in a previous video. 3x plus 2y equals 4, and 2x minus 4y equals 5. So the goal of elimination is to be able to add the x terms together and get them to cancel out, or to be able to add the y terms together and get them to cancel out. Right now, if we were to add the x terms, we would get 5x, so they wouldn't cancel out. And if we add the y terms together, we will get negative 2y, so they won't cancel out. But we could get them to cancel out if we were to note that multiplying the first equation by 2 and the second equation by negative 3 would make the coefficients in front of the x be opposite of each other. So the coefficients are 3 and 2. So if they have a common multiple of 6, and if I multiply one of them by a negative value, I'll get a 6 and a negative 6 in front of my x terms as my coefficients for my x terms, and then they will add to 0. So let's see how that works. So if I multiply the first equation by 2, I end up with 6x plus 4y equals 8. If I multiply the second equation by negative 3, I end up with negative 6x plus 12y is equal to negative 15. When I add the equations up, 6x plus negative 6x would add to 0. So in other words, I'm adding the left sides together and I'm adding the right sides together. So what we're left with on the right-hand side is 4y plus 12y, or 16y. And on the left side, we end up with on the right side, we end up with negative 7. Now we can solve for y by dividing everything through by 16. And we determine that y must be negative 7/16. We're not finished the problem yet because our goal is to get an xy coordinate. So we need to substitute the y value back into one of the two equations. Let me substitute it into the second original equation. So 2 times x minus 4 times, instead of y, we'll write negative 7/16 must equal 5. We can simplify this down by dividing a 4 out of the numerator and denominator of the second term, and get that 2x plus 7/4 is equal to 5. And then we can multiply everything through by 4 to simplify this process. Get that 8x plus 7 is equal to 20. That eliminates having a denominator. Now we can subtract 7 from both sides and get that 8x is equal to 13. So x is equal to 13/8. And this corresponds to what we had determined before. Now it turns out there's an easier way to solve this problem. Just looking at the possibility for x first sort of blinded us to what we could have done for y. It would have been easier to note that 2 and 4 are much more nicely related. If I simply multiply the 2 by 2, it will in fact be 4. So the least common multiple is 4, and the 4y has a negative in front of it. So if I were to simply multiply the first equation by 2, I could have a successful elimination of the y variable. So if I multiply the first equation by 2, I once again get 6x plus 4y is equal to 8. And I can simply rewrite the second equation. So make sure you notice what happened here. By simply multiplying the first equation by 2, I'm going to be able to I have a 4y in the first equation and a negative 4y in the second equation. So we're ready to eliminate the y by adding the two equations together. So the sum of the left-hand side becomes 8x, and the sum of the right-hand side becomes 13. and I can very quickly get that x is 13 over 8. The same as what we had before, but it required fewer steps. So studying the equations prior to trying to multiply by the correct values makes it easier. Continuing on, now that we know what x is, we can solve for the y value by using either the first or second equation. And so this time I will use the first equation as it was given. 3 times, instead of x, I'm going to put in 13/8 plus 2y is equal to 4. At this point, I think it's easiest just to multiply everything through by 8. And so the first term becomes 39. When I multiply the second term on the left by 8, I get 16y. And 4 times 8 is 32. So I multiplied everything through by 8 to get that. Now I can subtract 39 from both sides and get that 16y should be negative 7. Therefore, dividing both sides by 16 tells me that y should be negative 7/16. So if we divide the page in half, you can see how much less ink was used on the right half of the page. So if we can find, when we look at the original equations, if you look at the 3 and the 2 and the 2 and the 4, it's much nicer to work with the 2 and the 4 than the 3 and the 2. We get to an answer much more quickly with less work. So look for patterns when you're solving these, and it'll make your life easier.